Section 11.3 is all about combinations. So we need to know the difference between a permutation and a combination and then solve problems involving combinations using the formula. So a combination is different from a permutation. Combination of items occurs when the items are selected from the same group. No item is used more than once. The order of the items makes no difference. So order doesn't matter with combinations. No item is used more than once. Okay, so we have permutation and combination. These are the hardest things to remember. But the way that I remember them is permutation is all about position. So order matters. So let's say the first, second, and third place. It matters. It matters if you get first place or if you get third place. Combination involves situations where order makes no difference. So this is called committee, combination committee. So this type of problem would be finding, okay, you have 100 people, you want to pick a committee of 5 people. So it doesn't matter the order there, you're just picking 5 people to be on this specific committee or in this group. Position, permutation, combination, committee. Okay, and we use NPR for permutation and NCR for combination. So let's answer these questions involving permutations or combinations. So you have to decide which one it is. So 6 students are running for student government president, vice president, and treasurer. Student with the greatest number of votes becomes president. Second highest gets vice president. Third highest gets treasurer. How many different outcomes are possible? We're not answering this. We are just deciding whether it's a permutation or a combination. So you'd have to ask yourself, is this about position or is this about a committee? Does order matter or does it not? The greatest becomes president. So this is all about position. The position you come in, the rank that you come in, determines which office you get. So it's position, meaning we are doing a permutation. Okay, next example. 6 people on a board of supervisors for your neighbor are on the board of supervisors for your park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees can be formed? So this has a committee. It doesn't matter what position they get chosen. So this is combination. So I'm going to write committee means combination. Order doesn't matter. Given the letters A, B, C, and D, we can compare how many permutations and how many combinations are possible if we choose 3 letters at a time. So this is listing out all the combinations, all the different orders for A, B, and C, right? A, B, D, A, C, D, and B, C, D. This column contains only one combination, A, B, C. This column contains one combination, A, B, D. This is one combination, A, C, D, one combination, B, C, D. So it's combinations, but if you change the order, those are permutations. So we only have 4 combinations, but permutations would be if order matters. We have 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6. 4 times 6, 24 permutations. So if order matters, then you're going to have more outcomes. If order doesn't matter, it's less outcomes. Here's the formula for combinations. So for permutations, NPR was n factorial over n minus r factorial. Well, here we are dividing by r factorial. So we are making it less. So let's look at these examples. So this would be 15 factorial over 15 minus 14 factorial, 14 factorial, 15 factorial over 1 factorial, 14 factorial, which gives us 15 times 14 factorial over 14 factorial, because 1 factorial doesn't change anything. It's just equals 15. So 15 different combinations. This one N and R, so we'll do 11 factorial over 11 minus 6 factorial times 6 factorial. The 11 factorial over 5 factorial over 6 factorial. So you can put that in the calculator. I guess I could show you all that. And then go back to that. 462. Okay, there is the NCR in the calculator. It's the same place as the NPR. So you can go to, well, we need to put in 15 first. So 15 math over to probability NCR. So it's 15 items, choose 14. There's 15 combinations. 11 items, choose 6, 462. Using the formula for combination, so a 3-person committee is needed to study the ways to improve public transportation. How many committees could be formed from 8 people on the board of supervisors? So we have a total of 8 people. We're choosing 3 people to make a committee. So it's just a committee, a group of people. Position doesn't matter, so we're going to use NCR. So it's 8, 13. So we can put that in the calculator. Oh, not 13, sorry, 3. You gotta put in the number first. So 8. Probability 56. You could also use that formula if you'd like to. Let me show you on my answer sheet. So you can put it in the formula like this. Comes out equaling 56 also. Example 3. Election ballot asks voters to select 6 commissioners from a group of 22 candidates. How many ways can this be done? So we have N is 22, R is 6. So we use combination. Or you can use the formula. Example 4, using the fundamental account formula for combinations and fundamental accounting principles. How many members can a committee of 11 Democrats, or 3 Democrats and 4 Republicans be formed from a group of 11 Democrats and 11 Republicans? So we're actually choosing for the Democrats and we're choosing for the Republicans. So the Democrats, we have 11 Democrats and we're choosing a committee of 3. Then we have 11 Republicans and choosing 4. So we can actually multiply these because we're finding out how many different committees can be formed for Democrats and for Republicans. So we'll multiply those. So I'm just going to find what each one of them is and then multiply them. 165. Let me just go up and drag this down and change that to a 4. If you choose 4 people, it now turns to 330. So we multiply those. Okay, so that's how many different ways a committee can be formed. Quite a few. All right, example 5 has 3 problems that you're going to determine whether it's a permutation or a combination, and you're going to find out how many outcomes there are. In a race in which 11 automobiles are entered and there are no ties, how many ways can the first 3 finishers come in? So this is position, because it matters if they're first, second, third. So that means we're going to do a permutation. So we have 11, and we're choosing the first 3. So 11, choose 3. You put that in the calculator. Oh, we did that one a minute ago. No, that's a combination. I was going to say, oh, it's 165. But this is a permutation, so it's going to be different. 990. Now here are 90 different ways you can have your first 3 finishers come in. From a group of 20 people, how many ways can a group of 6 members be selected to attend the conference? So order doesn't matter here. So it's just a committee. A committee is going to go to the conference. So that means this is a combination. So we have n is 20. Group of 6 members are selected. So we're doing combination. And one person has 6 dress shirts, 8 ties, 3 jackets. In how many ways can that person select a dress shirt, a tie, and a jacket for work today? So this is just that fundamental accounting principle. That's what we did on 11.1. We're just multiplying all the possible outcomes. So let's multiply. 44. All right, let's see it.